Good, 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 good. Ju- Judging by the sound of the claps, sounds very good.
Oh, it's excellent. Excellent.
Judging by the sound of the claps, it sounds very good. Did you hear
Don't.
that?
Wasn't me.
I know, it was the guy backstage. Do it again, do it again. I just wanted to applause. Hi! You well? 5 of you are well. What's the matter? Was the last talk was good, right? You're feeling energized, you're feeling inspired. Amazing. My name is Tejas. That's pronounced like contagious, but don't worry, I'm not contagious. I'm not going to give you anything besides hopefully a good talk. And I have to say, I love this conference. I was here for CSSConf and JSConf yesterday. Learned a ton. I learned a ton. Debugging, performance, it's all here. Can we hear it for the organizers of JSConf Budapest? Absolutely. Incredible. And also the city. The city is really beautiful. If you live here, whew, I'm jealous. I'm jealous. So as I said, my name's Tejas. Contagious is kind of like a way to remember it because it's a bit of a different Indian name. But really, at this point, you can just call me that joke guy from yesterday. Like yesterday at the party, it's like, eh! And so, yes, I'm hilarious. I work in Germany at a company called Contiamo, and the marketing way we promote ourselves is we accelerate data access, which just means we help people understand their data and do all kinds of cool data sciencey things. But really, for me, what I love the most about my work is these people. Oh my goodness, this is my team, and they are some of the brightest, funniest, smartest. Oh my goodness, I love them very much, and I'm very happy to work with them, and I get to come here and tell you about how wonderful they are. But that, unfortunately, is not what this talk is about. It's very sad. Instead, the talk's about serverless. How many of you have heard of serverless? Wow, everybody. So nothing new will be learned here. I'm just kidding. We're going to talk about serverless. We're going to look at some adoption, some usage. We'll look at what it means and why I think it is absolutely revolutionary. And I mean that. This talk is called Legendary Lambdas for a reason. But before we get into that, let's kind of look at some facts and figures. These are from surveys. The citations on the bottom left, I'd encourage you to go look it up. And according to the new stack, some time ago, about 78% of participants in the survey wanted to adopt serverless into their ecosystem, into their internal service architecture. 78%, which means by now they may have already. Another interesting statistic is 75% of the problem space has been penetrated by serverless in the last 18 months or so. And that is really, really, really exciting. It very quickly overtook the prior art, if you will, containers as a service. And it's growing very fast. And these are just numbers, but there are real-world use cases where serverless is doing amazing things. And one such use case is by one of the biggest brands in the whole world. Coca-Cola reduced their operating costs by about 65% on serverless. And how they did that is they had these vending machines that were like 10 to 12 years old. And they would have to send some telemetry. They would have to send some information about are there enough drinks and stuff to Coke. Now, these, up until 2016, were run on Amazon's EC2 and cost about $12,864 a year. Okay. After moving to serverless, Coca-Cola pays $4,490 roughly at the time of the case study per year. That's a 65% reduction, and they could serve 30 million requests at one time, at the time of publishing of the study. Very, very, very interesting. Second, if you've ever played or heard of Final Fantasy, Square Enix is the company behind some of the world's greatest MMORPGs, massively multiplayer online role-playing games, and they can have millions of players on at the same time. And what players like to do at massive scale is take screenshots. So they have an image processing function that would process these screenshots. Now, processing these screenshots, especially under heavy load, used to take several hours. After moving to serverless, these take a little over 10 seconds. And more than that, they can comfortably do this with traffic spikes of over 2 times. So if there's a gaming tournament and there's like millions of people online, this function to process the images eats it for breakfast. Lastly, if you've ever heard of or used a Wi-Fi router in your entire life, there's a good chance it was a Thomson one. And Thomson routers, one of the world's biggest brands for routers, is able to process 4,000 events per second on serverless. What's really impressive about this is even, under very heavy conditions, there's no or minimal, probably no data loss. But for me, and this is what I want to focus on today, is they scheduled 5 months to get this into production, according to the report. And if you're at the scale of Thomson, 5 months is a really short time. I've heard people say that in larger companies, things just take longer. There's more meetings, there's more planning, whatsoever. And so 5 months is ambitious. Thomson actually ended up moving this thing to serverless 2 months ahead of schedule. 2 months ahead of serverless is you're able to get up and running really, really fast. And so I tell you all these things to tell you it's here and it's big and people are talking about it, but don't take my word for it. I think one of my friends, Nader, said it best. He just says this: serverless is the future. And so if it is the future and we're all kind of going there anyway, let's spend 30 minutes talking about it in a little bit of detail. So what is it? What is serverless? Serverless, in quotes. It's a loaded term, right? It could mean functions, which we'll talk about, but it could just mean like static websites, Jamstack things. I want to make a point here that may be controversial, but you know what? It's you love me, it's fine, whatever. I think just the word serverless is kind of a lie. Like, in English, it's called a misnomer. Mis as in not quite, nomer as in name. Now, in software engineering, naming things is hard, and I think we may have missed serverless, because I was talking to my wife about it. She studies law and isn't very involved with tech, and it sounds like, well, there's no servers at all, which is a huge lie. And so, I'd invite you to consider this. It's a wireless charger. Also kind of a lie. And so serverless is kind of like that. It doesn't mean there are no servers. It means that they're not your problem. You do what you love. You get to focus on building the apps, the experiences you absolutely love, and you pay Amazon or Zeit or Netlify or one of these some amount of money or use their free tier, and your stuff's magically in the cloud. Serverless, you can quote me on this, serverless brings the cloud down. But why? And there's a number of reasons why serverless is so popular, and we'll go through them. I think you know them. They're not like rocket science or mind-blowing. But as I just said, you can focus on the things you love. You delegate the responsibility of servers to someone else. So you write your JavaScript. You write your Python, if you're into that. And you put it in the cloud. And the concerns of provisioning the server, setting up the runtime, getting it up, all of that, you don't deal with. If for some reason your server dies and you need to send traffic to a different machine for whatever reason, handled for you. That's already, like, I can breathe a little bit easier. Number 3, scale. Like, if for example, you're Square Enix and there's a huge gaming tournament, you don't have to think about scaling vertically by adding more memory or hardware, throwing hardware at the problem, or scaling horizontally by adding more servers in your cluster. Doesn't matter. You create the software you know and love. And these are kind of the 3 tenets of serverless, but I invite you to consider one more, and that is this one. You see, most tech conferences, I think it may be fair to say all tech conferences are on this spectrum of technology and community. And JSConf family conferences that I've been to usually lean a little bit more towards community. And if we're in community, we need to talk accessibility. In case that's not big enough, accessibility. I think serverless makes the web, the cloud, so accessible that everybody can play. And this is huge. You see, I was born in a country that is poor. It's a developing country. India, in case you were wondering. I love the food. It's amazing. but the country is it's growing, right? And the prior art of serverless means you have to have some type of server. It means you have to either get shared hosting if money's tight, or you get a virtual private server, or a bare metal server. Now, with these, there's money involved. And sometimes, for some communities, this money is too much. It's not as accessible. With Lambda, serverless helps these communities. See, India, I think, is home to some of the most brilliant minds on the face of the planet. And if you need evidence of that, you don't have to look very far. CEO of Google, CEO of Microsoft, Sunil Pai at Facebook. There's React India is happening right now, and there's a whole bunch of them ready to learn and grow. The problem is, the cloud is not accessible because you pay so much for a server. It's unbelievable. Lambda has this pricing model that allows people from these communities to put stuff in the cloud. You have an idea, put it in there. And how that's possible is because Lambdas are functions. They're just functions. There's an excellent talk yesterday on functional programming. They're functions. And as we saw, functions, what do? You write them, they start, they do a job, they run to completion, they finish, they return a value. That's it. In a perfect world, your functions are stateless, or as in they close over their own state, they have no side effects, and they're pure. Meaning for any given input, they give you the same output without side effects, so they're predictable. If they're predictable, they're testable. You can unit test them and make sure they behave the way you want them to. If they're testable, they're scalable, meaning you can run 50 different versions of the same function, they do the same thing. And if they're infinitely scalable, you can go really, really, really far. And so if the functions are invoked, it presents an entirely different pricing model. Previously, you would pay monthly for a server. People use it, people don't. I don't care. I'm losing 350 euros a month just paying for a server. I'm wildly unpopular. I'm paying for a server. I can't pay my rent, but maybe someone will use it and it'll catch on. I'll just keep hope and pay for this. I lose money a whole year. With Lambda, you pay for each time your function is invoked. And I think that's a game changer. I really do. Because if no one uses your thing, you pay nothing with some providers. If one person uses it, you pay, I think it's like 1/5 millionth of a dollar. You pay for invocations and you pay for compute time. We'll talk more about that, but it's almost free. And if it's almost free, no matter how much money you or your country has, you can put stuff in the cloud. I think that's incredible. And so I thought I could show you some examples if the internet cooperates. If it doesn't, we'll see what happens. And so here's an example. Here's a serverless function in JavaScript because it's JSConf. And I'm sending. So I have a request response set of arguments, and I'm sending through the response a heading of the current date and time. Let's put this in the cloud. I want you to pay attention because this is super sophisticated to put stuff in the cloud on serverless. I'm using a provider. There's others, but I find this easy. And I just enter one command, literally one command. And it says, OK, I'm deploying this function. Damn, bam, it's done. And I open it. And so what happens is that function's called when I open the function. And it returns a value to the browser. This calls the function, and it calls the function, if I reload the page, it calls the function every time, you see. And so I'm kind of running up a huge bill here by reloading this page, but it's not very much. I'm sure I can afford it. I'm actually on their free tier, so I'm sure I can afford it. But another case for serverless, if you want to get creative, is this thing, which will automatically give you a randomly generated thinking emoji on every invocation. This one apparently is huge, but every time you reload the page, you just get a new one. Because the function is called on many. I could do this all day. Okay, moving on. So what we saw was cool. I don't know why my dock is showing. Like, Apple, if you're watching, please, quality. The pricing for that, though, is that much. You pay for each time it's invoked, you pay that much. And you pay for the amount of gigabyte seconds you use. And this is on Amazon Web Services. That's crazy. But I spend a lot of time in a lot of tech conferences talking to a lot of people about things, about serverless, about CSS, about life and love and Romeo and Juliet, whatever. And as with everything, there are concerns. Can it be that good? Is it too good to be true? The two big concerns I hear often are acceptance of service. So a traditional problem with servers is denial of service. You get hit with too many requests, and then your server is like, I can't deal with it, I quit. And it denies service. But with serverless, since it scales up, the other side of the problem is true. If you pay for each time your URL is accessed, someone could just like while true and then fetch you every time. You know what I mean? And then they just send request after request, and then you get a bill of $2 million. How do you deal with that? Number two, if you say, Tejas, if you say our lambdas need to be stateless and pure, but I need a database. How do I do this? We'll talk about those. Let's start with acceptance of service. Let's go down a hypothetical journey. Okay? Let's say your worst enemy sets up a network of 100,000 bots. Okay? And they just like keep hitting your server for 60 minutes, one request per second. Okay? That is a total of 360 million in an hour Lambda invocations. It's big numbers, big and scary. It's even physically big on the screen. So that's a lot. Let's add to the equation. Let's say your function takes 200 milliseconds of compute time and uses a gigabyte of memory. Okay? These are just factors for a little experiment. Now on Amazon Web Services with Lambda, this is what you would pay. It's a 2-digit number for invocation, $72, and since it's 1 gigabyte of memory over 200 seconds, it's $1,224. All of that to say, in an attack at that scale, you pay less than $1,500. You would pay that anyway on a previously server-based solution, if not more. So this is an extreme case. And I think if you're an early stage startup or a late stage startup or whatever, that's within reach. And if you're attacked at that scale, you're probably famous enough to afford it. Maybe. And there's services. There's something called Amazon CloudWatch that will kind of watch your thing and warn you if you're getting too much traffic. So there are measures you can implement to prevent this. I think that's pretty okay. Second problem, the need for state. I need state. We all need state. They kind of can't have an app without state. How do we do this? Every time I talk about serverless with someone, I don't know why, but the thinking goes to like, okay, everything needs to be a function. Everything's pure, everything. Like, we love this in JavaScript. Like, someone says something about Gatsby, we're like, move everything to Gatsby. Someone says something about React hooks, we're like, hooks everywhere, classes are evil. You know, like, everything doesn't need to be a function, okay? Use it in moderation, use it with consideration, but perhaps you have a MongoDB Atlas or Hasura database on Postgres, the GraphQL API somewhere. Great. Maybe there's a place for your function at the API layer. Maybe there isn't, but not everything needs to be a function. Yes, you can have your state. You can even eat it if you want. You didn't understand that. That's okay. Not everything needs to be a function. And so that brings me to the study. Part of this talk was to discuss briefly a study that I did literally for science. I have to preface this multiple times by saying, don't do this. It's one of those things that you do because you're curious. Don't do it in production. There's better ways to do this. Jamstack is a good way. Other ways too. But anyway, I wanted to try out serverless, but like with UI. So I took some frameworks and did some stuff with Lambdas, and we'll see some results. But how do you do like a UI as you know? So you have UI, and you want to put it in a Lambda. But is your UI a function, or is it like divs and stuff? I've heard, actually, no, wait a second. Your UI is a function of your state. Like, this is like the E equals MC square of UI development, isn't it? Like, UI is a function of your, okay, I can see that. Wait a second, that means UI can just be a Lambda. Whoa! Okay, cool, let's try it. Let's write, like, React DOM.render to string on a Lambda, and that's exactly what we did. We server rendered a UI, as a serverless Lambda. So I guess that's serverless server-side rendering. Is that SSSR? USS? No, don't make that joke. Seriously. The study, we we looked at some leading UI frameworks. So we looked at Preact, React, Lit HTML, that's the polymer icon. Please don't be offended. Vue and VHTML, so 5 frameworks. And what we wanted to do was, we wanted to build a Reddit clone. And this is just a clone of Reddit. It uses a flat file as the backend, so we don't really talk to the Reddit API, and that's to reduce latency and standard deviation when we benchmark. And the reason we chose server-side rendering, there was an excellent talk yesterday actually by Surma and Jake about, they talked a little bit about server-side rendering. It's just better. If you're not server rendering, I think it can be better in many cases. Partly because everything's delivered to your users in one network hop. Like they visit your page, bam, they get exactly what they want. There is no like, oh, my JavaScript bundle is loading now. Like some of you have seen these experiences on the web where you get a shell of an app and then spinners immediately. Server-side rendering just gives them what they need. It's also better for you in terms of search engine marketing. I heard at, I think at Google I/O actually, that it's significantly harder for search engines to index these things. As well, users don't like spinners. But one benefit you get actually with serverless and server-side rendering, again, probably not a good idea, is you get analytics out of the box. So imagine you have a blog, and each article is deployed as a Lambda. So if from article A, your serverless bill is $2, and article B, your serverless bill is $200, you kind of know what kind of content to be producing from there. I thought that was interesting. But regardless, so this is what we wanted to build. And we wanted to track 3 key metrics. Metric number 1 is the cost of booting the function cold. We'll talk a little bit more about this because it's a little bit exclusive to serverless. Number 2 is the Lambda size or the package size. This is a concept you're aware of. And number 3 is the throughput. How many requests per second can this handle? But let's talk a little bit about cold boot. With Lambdas, how they execute is they're these ephemeral containers. Like somebody accesses your URL, and then a container spins up. It npm installs JavaScript ecosystem. npm installs your dependencies, gets ready, then executes the function with importing your npm modules, returns a value. There's a bit of ceremony there. And that ceremony can take time. That's called a cold boot. This is best visualized with this graphic here. So a request comes in, and it downloads your code and boots, and then your code runs. Once your code runs, the function is considered hot or warm. It's ready to serve more requests, and it stays hot for a while. But after a while, they wind down and go cold again. There's a typo in the text. I hope you don't see it. And after a while, so that's kind of how cold boot works. So we wanted to test which framework required the most resources to start. Let's talk briefly about the code involved. The code for all of the Reddit examples with React, Preact, and VHTML, I believe, was the same code. Exactly the same code. How do you do that? Well, using this thing. How many of you have heard of Hyperscript? I can count on my fingers like 5. Hyperscript is it's just a function signature. And it's the function signature of something you're maybe more familiar with, React.createElement. It takes the tag of the element, the props, and the children. And Preact and VHTML, they implement this interface as well. And so what we ended up doing was you just kind of assign H to one of these 3, and the rest of the code stays exactly the same. It was really cool. For Vue and Lit HTML, we had to take a different strategy, because with Vue, you work with Vue instances. But we ended up copying the HTML string rendered and just interpolating with some Vue there. It's important to note here, Lit HTML doesn't have a node implementation, I don't believe, so we used a fork. And so the moment we've all been waiting for, the talk is almost over. No, we're going to look at the results of this briefly. But again, as I said in the beginning, do not have like a blog that's all Lambdas. I'm not sure that's the best way to do it. But if we're talking about the best framework on serverless, the answer is very much no, don't do it. Don't do it. Really, just use the platform. It's amazing. Seriously, you can even use the Jamstack or like vanilla. Seriously, like just don't even. Anyway, have I made my point? But the results, regardless, in case you're curious about numbers, are VHTML is really fast. And you just write JSX. It looks just like React, but what ends up happening is it doesn't have a virtual DOM, and that's why it's fast. So what it does, it takes your like JSX and turns it into a string of HTML that you can then return from your Lambda. And because of this, super fast and super light, coming in at 28 kilobytes. Preact naturally was the second. In fact, if you chose to do this for for science, you could server render VHTML, hydrate with Preact, and you have a really fast and pleasant experience. Unfortunately, coming up at the rear was Vue, which I don't think is necessarily a bad thing. The purpose of this study, kind of like the purpose of this talk, is to get us a little bit more serious about serverless, right? Is to get us to think about serverless a bit more. It's not to bash Vue, but it's to think about serverless. And so I was actually I feel like my work on this was how do you say, was vindicated, was successful, because the author of Vue noticed the study and responded with, maybe we'll revisit this when we optimize for serverless in the future of Vue. And this is the goal. I think because, as Nader said it so eloquently, serverless is the future. Because it's the future, I think we all should start thinking and optimizing for serverless in the new future. With that, let us land this plane. It's been a beautiful journey. I enjoy talking. I could talk all day. I'm not sure if you could listen all day, so we'll wrap it up. We talked about how serverless is the future. We looked at how Coca-Cola, Square Enix, others are really benefiting for serverless. We looked at how community matters. See, I feel like some of you may not get the weight, the potential of serverless to be truly legendary, because for most of you, you do your job and git push, and your ops team puts it in the cloud. Your ops team, though, may be losing sleep. Your company may be spending more than necessary. Maybe it doesn't directly impact you, but I truly believe serverless has a positive impact on your company and your team. But by and large, the positive impact, as I mentioned, is in poorer communities financially. It brings the cloud down. It makes it available to the rest of us. And I truly believe through these legendary Lambdas, we're going to see the world change for the better. We're going to see India develop and other nations like it develop faster, that lead to human satisfaction, happiness, joy, and flourishing. And with that, I want to say thank you very much for your time and for listening.